So now we will do Bresenham's line generation algorithm to draw a line having slope greater than 1. Previously we have done for slope less than 1, now we will do for slope greater than 1. So when the slope is greater than 1, the line will be bending towards the y-axis. So now the line will be bending towards the y-axis because the slope is greater than 1. So I will declare some variables, that is, let x1 y1 be the starting point. So x1 y1 will be starting point on the line. So I will name it as x1 y1 starting point, and x2 y2 be the end point. So let x2 y2 be the end point on the line, and xi yi be the ith point on the line. So I will name this point is xi and this point is yi. So it is the ith point on the line. So for x coordinate it will be xi, and for y coordinate it will be yi. And let xi plus 1 and yi plus 1 be the I plus 1th point on the line. So I plus 1th point on the line. So these are the variables which are declared. Now as m is greater than 1, so when the slope is greater than 1, the conditions, that is yi plus 1, means the y coordinates will remain unchanged. So its coordinate will be yi plus 1. But in the case of x coordinate, that is xi plus 1, it will be, or it may be xi or xi plus 1. So when the slope is greater than 1, the y coordinate value will remain same, but in the case of x coordinate value, that is I plus 1th pixel, for I plus 1th pixel, it will have two values, that is xi or xi plus 1. So now consider a point on the line, consider a point on the line whose y coordinates is yi plus 1 and x coordinate is x. So which means that it is unknown. So for calculating this unknown value of x, so now here x is unknown, so x is calculated by equation of line. So we will calculate the value of x. So x can be calculated using equation of line, that is y equal to mx plus c. So y equal to mx plus c. So here we know the y coordinate and the x coordinate is unknown. So the y coordinate value is yi plus 1 and x coordinate value is x, which is unknown and it is to be calculated. So now I will replace y as yi plus 1 and mx plus c. So now I have to calculate the value of x. So yi plus 1, so I will shift this c on left hand side, it will become minus c, it will be mx. So x is equal to y plus 1 minus c upon m. So by this equation we can calculate the value of x. So now we will consider a distance for finding the condition that xi plus 1 is equal to x or it is equal to xi plus 1. That is this conditions. So for finding of this condition, I am considering two distances, that is d1 and d2, whether I have to take xi plus 1 equal to xi or xi plus 1 equal to xi plus 1. So I will consider two distance, that is d1 and d2. So consider a distance d1 and d2 as shown in this figure. So on the basis of this distance, that is d1 and d2, we can get to know the values of xi plus 1, which is xi or xi plus 1. So now I will note down the coordinates of this point. So the coordinates of this point, so here basically there is a line where xi is the ith point on the line and y is the that is ith point on the line, and the distance between two columns are 1 and distance between this two row is 1. So for getting the coordinates of this point, the x coordinate will be xi plus 1 and y coordinate is yi plus 1. For this point, the x coordinate is x, which is unknown, and the y coordinate is yi plus 1. So the y coordinate is yi plus 1. So I will write it as yi plus 1. And now for the value for this coordinate will be, so the x coordinate will be, since it is in this point, so the x coordinate will be xi and the y coordinate is yi plus 1. So now the coordinates has been found out. Now the conditions are there. From the figure we can see that we have two distances, that is d1 and d2. So we have two figures. So from both the figure it is clear that one of the distance, that is here d1 is smaller and d2 is bigger. Here d1 is bigger and d2 is smaller. So on that basis we can calculate or we can come to know whether the I plus 1th pixel for x is xi or xi plus 1. So here d1 is less than d2. So here d1 is less than d2, which means that d1 minus d2 is less than 0. So in that case the yi plus 1 coordinate, that is y coordinate for I plus 1th pixel, remains the same. So it will be yi plus 1, but for xi plus 1, here we can see the closest pixel from this point, that is d1, is the closest pixel. So this is that point on the line. So the point on the line, so this pixel is closest and this pixel from this point is farthest. So in this case, we have to consider the coordinate of closest pixel. So here the closest pixel is D1, closest pixel is D1. So we will take the coordinates of closest pixel. So the coordinate of closest pixel, whose y coordinate is yi plus 1. So it is already written, and x coordinate is xi. So I will write it as xi. So similarly for figure 2, here you can see that D1 is greater than D2. So I can write D1 as D2, which means that D1 minus D2 is greater than 0. So D1 minus D2 is greater than 0. So the condition for difference in distance is greater than 0. Then at that case, I will note down the coordinates. So the coordinates of this pixel, that is D2, is xi plus 1 and yi plus 1. And for this one, it is xi and yi plus 1. So from the figure, it is clear that this pixel is closest to this point, that is on the line, and this pixel is farthest to this point, that is on the line. So we will choose the closest pixel. So here closest pixel is D2. So we will take the coordinates of D2. So now yi plus 1 is equal to yi plus 1 and xi plus 1. So the coordinate of xi plus 1, since we have to consider the D2 pixel, so I will take as xi plus 1. So it will be xi plus 1. So from this figure, we can identify the values of, that is coordinates of xi plus 1. So for D1 less than D2, the coordinates will be xi. For D1 greater than D2, the coordinates will be xi plus 1. So now from this figure, D1 so from this figure, D1 equal to x minus xi. So you can see the distance D1. So I want this distance D1. So this distance is x. So and this distance is xi. So the total distance is x and this distance xi. So by subtracting this value with this value, I will get this value. So that's why it is written as x, that is this value, minus xi, that is this value. So difference I will get D1. Similarly D2, so for D2 the total value is xi plus 1. So I will write xi plus 1 and I know this coordinate as x, that is this value as x. So subtracting this value with this value, I will get D2. So that's why xi plus 1 minus x. So now I will write D1 minus D2. So I know D1 as x minus xi and D2 as xi plus 1 minus x. So after evaluating, I get D1 minus D2 as 2x minus 2xi minus 1. So after evaluating, I get the value of D1 minus D2 as 2x minus 2xi minus 1. So the value of this x I already calculated earlier, that is this one, yi plus 1 minus c upon m. So in the place of that x, I will put these values. So now I know d1 minus d2 which is equal to 2. So in place of x, I will write yi plus 1 minus c upon m, and this will be 2xi minus 1. So now I will evaluate. So I will get d1 minus d2 as 2 upon m yi plus 2 by m minus 2c by m minus 2xi minus 1. So I will rearrange so that I want to put this value, that is 2 by m, 2c upon m and 1 as one single variable. So I am rearranging minus 2xi plus 2 by m minus 2c by m minus 1. So I am rearranging so that I can put this whole term as a single variable. So the variable I am using for this term as k. So now the equation will become this d1 minus d2 equal to 2 upon m minus 2xi plus k. But I know that m is equal to dy by dx. So in place of m, I will replace the m as dy by dx. So I will get d1 minus d2 as 2 yi dy into dx minus 2xi plus k. So after evaluating this whole term, I will get d1 minus d2 dy into d1 minus d2 equal to 2yi dx minus 2 dy xi plus k into dy. So after evaluating, I get dy into d1 minus d2 equal to 2yi dx minus 2 dy xi plus k dx. So now this left hand side term, that is this term, I will name it as pi. So where pi is called as decision parameter. So it is called as decision parameter. So I am naming this whole term as pi. So the equation will become pi equal to 2yi dx minus 2 dy xi plus k dy. So this is decision parameter for ith pixel. So for I plus 1th pixel, so just replacing I by I plus 1. So it will become pi plus 1 2 yi plus 1 into dx minus 2 dy xi plus 1 plus k into dy. So I am just replacing the suffix I with I plus 1th pixel. So now I will name this at first equation and I plus 1th pixel as second equation. So now I will subtract equation 2 by 1, that is 2 by 1. So after subtracting these two equations, the final equation I will get, that is pi plus 1 equal to pi plus 2 dx yi plus 1 minus yi minus 2 dy xi plus 1 minus xi. So after subtracting both this equation, I get the final term as pi plus 1. So I am naming this as equation 3. So we know that the decision parameter, that is d1 minus d2, has two conditions. One is less than 0 and another one is greater than 0, which means that decision parameter has two cases, that is two conditions. One is less than 0 and one is greater than 0. So now we will use these conditions. So this is the final equations. So if pi is less than 0, which means that d1 minus d2 is less than 0. So in that case we know yi plus 1 is yi plus 1, that is I plus 1th pixel is yi plus 1, for I plus 1th pixel for x is xi. So that is yi plus 1 which is equal to yi plus 1 and xi plus 1 is xi plus, it is just xi. So now I will put the values of yi plus 1 and xi plus 1 in equation 3, putting these values in equation 3, that is this equation, that is this equation. So I will replace yi plus 1 and xi plus 1. So after replacing I will get pi plus 1 as pi plus 2 into dx. So I get the decision parameter as pi plus 2 dx for decision parameter less than 0. So I will give it as equation 4. So similarly for decision parameter greater than 0, that is if pi is greater than 0, which means that dy minus d2 is non-negative value, that is greater than 0. So in that case which means that it is this case, that is d1 minus d2 greater than 0. So in that case I plus 1th pixel for y coordinate will be yi plus 1 and I plus 1th pixel for x coordinate will be xi plus 1. So I will replace these values of xi plus 1 and yi plus 1 in equation 3, that is yi plus 1 is equal to yi plus 1, which remains unchanged, and xi plus 1 will be xi plus 1. So I will replace these both values in equation 3. So I will get pi plus 1 as pi plus 2 dx minus 2 dy. So I will name this equation as equation 5. So these equations will be useful for finding out the or generating the line algorithms for Bresenhams. So now we will plot for first pixel. So the condition for plotting first pixel. So condition for plotting first pixel, which means that the ith term is replaced by 1. So I will replace xi as x1, yi as y1 and pi as P1. So these all equations, that is xi equal to x1, yi equal to y1 and pi is equal to p1, I will replace this in equation 1. So our equation 1, so this is that equation under which we will replace as pi as p1, y as y1, xi as x1. So after replacing, I will get p1 equal to 2 y1 dx minus 2 dy x1 plus k dy. So I got the values for descent parameter for first pixel as 2 y y1 dx minus 2 dy x1 plus k dx. So but we know the value of k, which we already replaced or we used to avoid the term c. So k was k was 2 by m minus 2c by m minus 1. So earlier we replaced this value, that's this whole term, by k. I will use this term, it will be 2m minus 2c upon m minus 1. So I will put this, I will replace k as 2 by m minus 2c by m minus 1. So it will become p1 equal to 2 yi dx minus 2 dy x1 plus 2 by m minus 2c by m minus 1 into dy. And we also know that m equal to dy by dx. So I will replace the value of m wherever m is there by dy by dx. So I will get the corresponding values of p1 as 2 dx y1 minus 2 dy x1 plus 2 dx minus 2c dx minus dy. So this is the equation which I got after replacing the values of k and m. So I want to eliminate this term, that is term with c. So for that I have to do some adjustments. So I know y equal to mx plus c. So for first pixel, that is, it will become y1 which is equal to mx1 plus c. So I know m as dy by dx. So I am replacing m by dy by dx. So after evaluating this whole term or rearranging this whole term, it will become as 2 dx y1 is equal to 2 dy x1 plus c into 2 dx. So after rearranging, I get this whole term. So you can cross check that this 2 dy x1 and 2 c dx, that is this black pen, I am underlining this term and this term is common. So it is also available in this term. So I can replace this 2 dy x1 and 2 c dx as 2 dx y1. So just I will take the minus sign common, so that the sum will be 2 dy x1 plus 2 c dx. So I am replacing this 2 term with this single term 2 dx y1. So now it will become P1 equal to 2 dx minus dy. So after calculation I got P1 as 2 dx minus dy. So I will name this equation as 6. So this is the final equation. So by this we can solve the algorithm problems for slope less than 1 and slope greater than 1. So now we will see the steps of algorithms. That is Bresenham's algorithm to draw a line with any slope. So there are steps for solving the algorithms for generation of line for Bresenhams. So step 1 is declaration of variables, which means that whatever variables we had used, we have to declare it first. So we have used x1 y1, which is the starting point on the line, x2 y2, it is the end point on the line, because the line has 2 points, that is starting points and ending points. So I named starting point as x1 y1 and ending point as x2 y2. And xy is the current point on the line, and dx and dy. So dx and dy is difference in x coordinates and y coordinates, and p is a decision parameter, and I is the counter of loop, and sine x and sine y is sines of dx and dy, means the sines of dx and dy which we required for solving. And step 2 is initialization. So we have the values of starting point and ending point, so we have to give, that is we have to read x1 y1, that is starting point on the line, and read x2 y2, that is end point on the line. So the next step is the calculation steps, where we have to calculate dx. So dx is x2 minus x1, and that is difference in x coordinates, and dy is difference in y coordinates. So we have to calculate dx and dy firstly. So if dx is less than 0, then the sin x will be minus 1, and if dx is greater than 0, then sin x is plus 1, which means that if the value, that is difference value of x coordinate, is less than 0, then we have to subtract the value with original values. That is, if we have values of x as 2 and the dx value is less than 0, then in that case we have to do 2 minus 1, the final value of x I will get as 1. Similarly, if dx is greater than 0, so if dx value is greater than 0, then we have to take sin x as plus 1. So if the value is 2 and the value of dx is greater than 0, at that case we have to add the value with the values of x, that is 2 plus 1, which will be 3. Similarly for dy, and so first condition is for dy less than 0, in that case sin y is negative, that is sin y is minus 1, that we have to subtract the value with the original value of y. And similarly for dy greater than 0, at that case the value of y is added with plus 1 if dy is greater than 0. So the next steps is plotting of points. So plotting of points. So plotting of points for m less than 1. So we know that the line having some slope, the slope will be having two conditions or two cases, that is, one is m less than 1 and one is m greater than 1. So for here we will see for m less than 1. So in this case I will put x as xi and y as yi, and nextly I will check which one is greater, is dx is greater, dy is greater. If dx is greater than dy, which means that the slope, that is slope, is less than 1. So from this we can predict whether the slope is greater than 1 or less than 1 from the values of dx and dy. Then nextly we have to calculate p, that is distance parameter, as 2 dy minus dx. So this relation we have to use after this step. And nextly we have to put on the values of I as 0, 1, 2, 3 and put pixel x comma y, that is starting point. And distance parameters also having two conditions, that is p less than 0 and p greater than 0. So when I will get this values, that is the values of p, if it is less than 0, at that case the value of x will be x plus sin x, which means that the sin x, which is plus 1 or minus 1. So the original value of x plus sin x, so I have to add the values of sin x with this x, so I will get the coordinates of x, and the y, that is y coordinate value, will remain unchanged when the distance parameter is less than 0. If distance parameter is greater than 0, at that case we have to use the relation, that is x equal to x plus sin x and y as y plus sin y, and we have to write the relation for distance parameter less than 0 as p equal to p plus 2 dy. So when I will get the value of distance parameter as less than 0, I will write, or I will use this distance parameter relation. So when the values of distance parameter is greater than 0, then at that time I will use the distance parameter relation as p equal to p plus 2 dy minus 2 dx. So we have two conditions for distance parameter less than and greater than 0, and we will continue till I is less than or equal to dx. So this is a stopping condition. So this is for slope less than 1. Now we will see for slope greater than 1, that is plotting of points for slope greater than 1. So this is a condition. So starting is same, where I will put x as xi and y as yi, and we will check the values of dy and dx, that is difference of y and x coordinates. So for slope greater than 1, which means that dy will be greater than dx. You can see the values of dy is greater than dx, that's why the slope is greater than 1. So after this I will use the distance parameter relation as 2 dx minus dy, and nextly I will put the pixels, that is I equal to 0. So I have the starting point value, that is x comma y, so I have that values. On that basis there are two conditions for distance parameter. One condition is less than 0 and another condition is greater than 0. So for less than 0 I have to use this values, these two values, that is y values, that is y coordinate value. So y is equal to y plus sin y, which means that we have to use. So now we will see plotting of points for slope greater than 1. So plotting of points for slope greater than 1. So initial step is x equal to xi and y equal to y, that is we will use the starting point of the line, and now we will check the conditions, that is the calculated value of dy and calculated value of dx. So whichever is greater, on that basis we can predict the slope is less than 1 or greater than 1. So for slope greater than 1, the dy value will be greater than dx value. So nextly we will use this equation for distance parameter, that is p equal to 2 dx minus dy, and we will start the succession that is put pixel x comma y. So on the basis of this value, that is descent parameter, if the value comes out as less than 0, then I will use y as y plus sine y and x as equal to x, that it will remain unchanged, and I will use this relation p equal to p plus 2 dx, that is p initial descent parameter plus 2 into dx, that is difference in x coordinate. If the values of this descent parameter comes out as greater than 0, that is positive value, then I will use y as y plus sine y So if p, I get this value as greater than 0, that is positive value, I will use y as plus sine y and x as x plus sine y. So this difference is that between descent parameter greater than 0 and descent parameter less than 0. So for p greater than 0, I will use this relation, that descent parameter relation, p equal to p plus 2 dx minus 2 dy, and I will continue till I, that is counter of loop, is less than or equal to the value of dy. So these are the algorithm steps for slope less than 1 and slope greater than 1 for Bresenham's line generation. Thank you.